Myself, Srinivasan, working as a faculty in the Department of Mechanical Engineering at Sri Shanmuga College of Engineering and Technology. The last lectures we discussed about recurrent neural network, and now we are going to look at recursive neural network. Recurrent neural network is basically for the sequential data. Okay, for example, if you have a time series data, one can use it. For recursive neural network is for the hierarchical data or structured data, I can say. That we'll see now. As I said, the recurrent neural network is basically for the linear sequences or time series data one can use or speech. And these are the purpose that we have discussed a lot in the last lectures. And now we are going to look at recursive neural network. It is basically works based on the tree structures. So it has some hierarchical structures. For example, if you look at RNN, we have these are the inputs and everything is based on the previous hidden state. Okay. For example, if you look at here that it has some each hidden state will have some memory because the memory is basically the information flows from the past hidden state, the previous hidden state. Okay. So here that is a mathematical representation for RNN. Okay. This is for the weight of previous hidden state and this is the hidden state and this is basically weight and this is basically your input. Okay, so when you have this summation and the activation function is given over here, summation and activation, and it will get, you will have a HT value at a particular hidden state at particular time step t. Okay, so this is a way we represent in RNN. See, if you look at this recursive neural network, we don't we don't go by linear sequences. So here we look at hierarchical one. It is like a tree-like structures. So what we have here is that we move from bottom up approach from leaves to root. So this is basically a leaf, and these are the child node. I can say it is simple representation. This is child node. This is a parent node. Parent node. This is a parent. Okay, so the information flows from bottom to top. In case of RNN, it flows from left to right. Okay, so that is the representation here. This is basically a child node representation, and this is basically parent one. So this is the way it works. But this is works based on the linear sequences. Here it works based on the structured data. Okay, until unless it is not structured and we can't understand the relationship. Okay, so that's why it is used in NLP applications. Particularly, it can be widely used in sentiment analysis. Okay, so it tries to form a past tree. Okay, so as I said, it has a wide application in NLP and it forms a past tree. And how it does, basically it tries to combine the smaller parts, whatever they, suppose if you give any sentences, any words that will combine into pair phrases and that phrases will become a sentence. Okay, so how it works, basically we have the word embedding and words are converted into vector representations. Okay, so for example, if I say Tamil Nadu or Germany or what India, it will have some representation that adjacent words forms these phrases. Okay, and these phrases combine and form a larger phrases and finally we'll end up with sentences. Okay, so that's why it is called bottom up approach. Okay, so basically what is happening in recursive neural network, it forms hierarchical structures. Okay, it works based on the hierarchical structures. Okay, so the advantage of this is basically we can, since it is a hierarchical structures and it has a semantic understanding. Okay, and synthetically it is structured and it can help you to understand semantically. Okay, so that is possible in recursive neural network. Okay, so this can help in grammatical structures, phrasal relationship, compositional semantics, and hierarchical meanings. So these are the advantage of using recursive neural network. Okay. This is the way it works. Basically, as I said, it is basically moves flow from flow from bottom to top. So we have the input here. These are the nodes. Okay, these are the nodes with corresponding nodes. These are all called a child node, as I said, and it has a weightages, and we get the output of this is output. Okay, this is basically our output, and finally we have a true label, and we can calculate loss. So it has some sort of hierarchical structures. It moves from child to parent. Okay. So the meaning of sentence is basically a function of words and structure. Okay. So this is the way it works. Okay. So basically what is happening, it is, as I said, it is basically a feed forward network. It's similar to feed forward network. So what we do is basically we compute all node vectors, because so for example, each, as I said, each words are represented in terms of vectors. So that's why we are going to compute all node vectors, and we are going to, at the end of the root, we are going to find the loss. Okay, then once we find the loss, again we can update the weights. So that is the reason we have this back propagations. Okay, and this is the way it works across the tree. Okay, so once you find the loss, again change the weights by gradient descent algorithm, and it moves across the tree. This is a basic difference between RNN and recursive RNN. This is basically, I can say this is RNN because it is linear. It has some linear sequences. This is basically recursive RNN, recursive neural network. Okay. For example, each word, basically the country of my birth. So each word has some representations, vector embedding. So each word has some representations, and in a RNN, and some information flows from, some portion flows from the previous hidden state to present hidden state. Okay. So finally we get the representation here. In case of recursive neural network, this is the way it works. Okay. So in the sentence, basically we have the country of my birth. Okay. The country is, again, basically it's a phrases, sentences. And basically the flow is like this: sentence to phrase, phrase to words. Okay. Phrase to words. Okay. Phrase to words. So these are the noun phrases, I can say. Okay. This is the determinant. This is the, all these things can be combined, and it flows from basically, sorry, this flows from like this, words to phrase to sentences. So this is the way it works. This is the way it works. So if you look at this word embedding representation, the country of my birth, so it is represented like this. Okay. And again, if you combine this, you will get 1, 3.5, that is given over here. Okay. Then my birth is this one, and it is given over here. Okay. It is given over here. Again, if we combine these two, and we get this one. Okay. When you combine these two, of my birth will give you these values. So when you combine both, and how it is happening, the entire sentence is represented here. The entire sentence, basically the country of my birth is represented in 1, 5. Okay. So this is the way it works. So if you look at this RNN and recursive neural network, is slightly different. The last output is different. It doesn't mean we don't need to worry about those things, but the representation is basically slightly different from this recursive neural network representation is slightly different. The value that is in the recursive neural network is slightly different from the RNN, but it has the semantic understanding. Okay, so that's what we expect from recursive neural network. Thank you.